Hello, Davison Middle School Science students. I'm Mrs. Kashara, and you're not. Thank you to you know who says that. Anyway, if you did not catch how to actually play this game, you need to stop this video and go back and watch the previous video because they played one round of this, and I would like for you to use this information in the first round if you are not doing this at home. If you are not doing this at home, watch that video and then continue with this, and we're going to do rounds 2, 3, 4, and 5 with some data so that you can do this. It definitely is so much better if you are to print these papers off, cut out the air molecules, cut out the cocoa molecules, and have your worksheet with you so that you can record your information. But if not, I'm going to watch this and hopefully you can figure out what's going on. All right, so let's get our game board set up. And so we're going to show the game board. I'm going to have you put that down onto the game board area, not on me, thank you. And so you're going to take your cocoa molecules and your air molecules and you shuffle them up. Always shuffle, shuffle, shuffle. My helper, will you please shuffle? Thank you. And then you're going to set up 4 columns, and this is very, very random. Just take them. It's just very random, and set up 4 columns of molecules. I have the air molecules, and my handy dandy helper over there has the cocoa molecules. Hopefully you can see them. Now, because there's more molecules of air than there is cocoa, that is why we have more molecules of air. In fact, I think we have 20 molecules of air in this game, and I think there are 12 molecules of cocoa. So in our cocoa collision, the collisions happen in the zone. So about where the top of the cocoa, hot cocoa would be, and hitting the air, this would be where the collision happens. So we're going to take our cocoa molecule, help me out here, there you go, boom, we make a collision. And when we have a collision, this happens to be one that was from the first round, and it had 5 kinetic energies, and cocoa has 13 kinetic energies. Remember, the kinetic energy, there's more because the molecules are moving faster in the cocoa because it's hot. And so now I'm going to take these, I'm going to have 5, and I just took rocks, 1, 2, 3, 4, 5 rocks. And then the cocoa, there was 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. And we're going to bring them so that they equal out. 1, 2, 3, 4, 5. And then just equal these out. And it looks like we have one side exactly equal. So one side's going to be air, one side's going to be cocoa. And so now we count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have now 9 kinetic energies. And cocoa, you have how many?
9.
9 as well. And we must have had 18. So we're going to take that 13 and make that a 9. And so on our sheet, I went from 5 to 9, so that is a +4. And so on my sheet for air, I'm going to put, in round 2, I'm going to put a +4. And for the cocoa, you went from 13 to 9, so that's a minus in the second round, the first round. That's a -4. And then we're going to go to the next one. All right. Let's collide the air and the cocoa. Boom. And that one, we have 3 total kinetic energies. Cocoa has 4 kinetic energies. Bring those up. Now, if we even that out, there's 1 extra 1. And the rule is whoever has the lowest number gets the extra 1. So in this case, air has the lowest kinetic energy, so air is going to get that extra one, and then we break this apart, and you get that, and I have now 4 kinetic energies for air, and Coco has 1, 2, 3 kinetic energies. So on our paper, our air went from 3 to 4, that's a +1. And for the hot cocoa, it went from 4 down to 3, so that would be a -1. All right, let's collide the third molecule. All right, in this one, we have the air has 2 of them, and cocoa has 8. So we will partner those up, and it looks like, is this one part of it too? Mm-hmm. They're evened out. 2, 4, 5. You should have 5 on that one as well. And this one is 5. So on our paper, we have 2 to 5. That's a +3 for air. Cocoa went from an 8 to a 5, so that's a -3. All right. And let's have our last collision here with the air and the cocoa molecule in the collision zone. And so that has 2, and then you have 7. We'll even these out. And it looks like we have an extra one. And who gets the extra one? That would be air. They don't have as many, so air, and you get this, I get this, so I count out 2, 4, 5. Air goes to 5. And how many for cocoa? 1, 2, 3, 4. Down to 4. So then on our paper, air went from 2 kinetic energies to 5, so that's a +3 for air. And hot cocoa went from a 7 down to a 4, so that would be a -3. And thus we have our second round. Now, on our paper, if you take a look, what we did in the first round is you need to take how many total kinetic energies we started with, and air, in this case, was 55 total kinetic energies. And then we did whatever this is going to be, whether it's a plus or a minus, you're going to add those. When we get to the 4th molecule in each round, you want to take that kinetic energy and divide by the number of molecules you have. When you do that, you take your total kinetic energy divided by the number of molecules, you get your average of your temperature. So you can see in our temperature went from 2.75 to 3.55 in that first round. For this round, for the second round, you're now going to continue that same pattern, and you take the 71 plus the 4, which would be 75. 75 plus 1 is 76. 76 plus 3, 79. And 82. In this case, we take that 82 divided by 20. Need that handy dandy calculator, sir. Thank you. And we have 82 divided by the 20 molecules of air, and we get 4.1. Notice what's happening to the temperature. 2.75, 3.55, 4.10. Okay, that's just 2 rounds. For the cocoa, I'll just bring it right over here. For the cocoa, we had a lot more kinetic energy because the cocoa was hot. The molecules are moving around. When molecules are hot, they're moving, and that's what kinetic energy is, those moving molecules, moving energy. So we started with 117, and we subtracted these numbers because they were all minus. And then when we got to our 4th round, we took that last number and we divided by the number of molecules. We had 12 molecules of cocoa. And so our starting temperature was 9.75 and went to 8.42. Let's see this second round, what happens. So we have 101 minus the 4 is going to give us 97. Minus 1 is 96. Minus 3 is 93. and minus 3 is 90. We get to that fourth round, we're going to take that and divide by our 12 molecules. So I'm going to take 90 divided by those 12 molecules, and our temperature this time now is 7.5. And you can see what's happening to the cocoa temperature. Started at 9.75 to 8.42, now to 7.5. We'll say 50 since we're at the 100th place. So we got 3 more rounds to go. So hang tight. I think what we'll do is we will do the rounds for you so you know if it's a plus or a minus, and I will just let you do the rest of the work in over here in finding out the temperature, dividing it by the number of molecules. You've got 2 examples right here, and I'll let you finish up the last 3 rounds for that. But we will do all the rest here for you so that we can have that game done if you are choosing not to do that at home. All right, so here's your cocoa. You're going to have to set that phone down. We have to mix our molecules really well. And this is important if you're going to do this at home, because remember, this is all very random. This is not something where I can just pick the bottom ones up. It has to be very sporadic, very random. Can't just have the same molecules. Molecules are moving all over the place. So that's what we're acting like right here. Okay. And once we have that, we can set up our molecules in our 4 columns again. Sometimes you will have new molecules you didn't do any writing on, and sometimes you have molecules you've done it before. And I have all the air molecules on one side and all the cocoa molecules on the other. All right. This is our collision zone right here. So we're going to take the top 4 right here, and that is going to be what we're going to collide with. Now, we don't necessarily have to do the counters every time. Let's see if we can do this without the counters this time. All right, let's take the air and the cocoa, collide that, and we have 1 and 11. So 1 plus 11 is 12. And 12 divided by 2 is 6. So in this case, air is going to have 6 and cocoa is going to have 6. Again, if you want to do those counters, it's always fun and easy to do. But you guys know how to do math, I'm sure. And that's exactly what we're doing, is we're adding up those kinetic energies and dividing by 2. So in this case, we have air going from 1 kinetic energy to 6. So that's a plus 5 on that one for the air. And the cocoa is going from 11 kinetic energies down to 6, and that's a minus 5. All right, and let's do our next collision. Boom, 5, and now this one you can see had a collision before, and we're just going to use that, not the first one, but the one that was in the next box. So 5 plus 4 is 9. And so we have an extra one. We're going to keep that extra one, so that would make 8. Divided by 2 is 4. And who has the smallest one? Cocoa has the smallest one. So this time, cocoa is going to get that extra molecule. So we had 9 minus 1 is 8 to make it even. 8 divided by 2 is 4 and 5. So cocoa this time is going from 4 to 5. Air is just having 4. So this time, this is interesting. We haven't had this. Now air is going from 5 to 4. That's a minus 1. That's the first time we've had a minus 1 for air. And cocoa went from a 4 to a 5. That's a plus 1. And that's the first time that's gone for that. Kind of interesting. All right, let's collide these two together. This one we have 5 kinetic energies and 3 kinetic energies. That makes 8. 8's easy to divide by. That gives us 4. 4. And let's see. The air went from 5 down to 4. Air got another minus 1 in this case. And the cocoa went from, is that a 3, up to a 4. That's another plus 1 for that one. Interesting. All right, let's collide these. 4 and 5 is 9. In this case, we have an extra 1. And then take that extra 1 minus that from 9 is 8. 8 divided by 2 is 4. And whoever gets that extra 1 is the lowest number. In this case, it's air. So air is going to get not only 4, but plus that extra 1 to make it 5. Cocoa is going to get 4. And so air goes from a plus 1, 4 to 5, and cocoa goes a minus 1. All right, ladies and gentlemen, again, what I'm going to have you do is you're going to do the work for the total kinetic energies. Tell me what the total kinetic energy is, and then make sure at this point when you get to the fourth one, you're going to take that total and divide by 12 to give you your temperature for cocoa. For air, you're going to do the same thing here. Take your kinetic energies and do whatever it's telling you, plus or a minus, and then when you get to the fourth one, divide that one by 20. And that will give you your temperature. And I'm going to let you do that. All right, let's mix it up. We're going around 4. Mix, mix, mix. Remember, these molecules are floating. They're moving all over the place very randomly. Whoop, I need an air. Don't take mine. Cocoa Man over there. Should be drinking hot cocoa while we're doing this game. I advise you, if you're at home and you have some hot cocoa, get some hot cocoa. This would be fun. All right. Very random. Just thank you. All right, got our column set up, and now for round 3. Here we go, air and cocoa collide, boom. We have 6 and 13. Sorry about that, folks. 6 and 13, 6, 7, 8, 9, that's 19. That's an odd number. Minus 1 from that would give you 18. So we have that extra. 18 divided by 2 is 9. And the one who gets that extra 1 is air, because air only has 6. So here, air is going to get 10, and cocoa is getting 9. So in this round, air went from 6 to 10. That's a plus 4 for air. And cocoa went from 13 to 9, and that's a minus 4. All right. Okay, I can get those out of the way. Thank you. Let's do our next collision. Boom. 8 plus 2 is 10. Divided by 2 is 5. So 5 kinetic energies. And air would be a plus 3 that round. Cocoa would be minus 3 for that second round. All right, let's take this molecule. Boom. 6 plus 2 is 8. Divided by 2 is 4 kinetic energies. Air would have 2 to 4. That's a plus 2 for air. Cocoa went from 6 to 4. That's a minus 2 for cocoa. And let's collide this one. Boom. 2 plus 4 is 6. 6 divided by 2 is 3 kinetic energies. 3 kinetic energies. So air went from a 2 to a 3. That's a plus 1 for air. And cocoa went from a 4 to a 3, and that's a minus 3. So we're done with that fourth round. Oops, minus 1. Sorry about that. And so you're going to, again, continue your total kinetic energies, doing whatever your minus or plus. And when you get to the fourth one, divide that by 12 molecules for cocoa. And do the same here, plus or minus, to your adding of your total kinetic energy. And when you get to the fourth round, divide that by the number of molecules that you have to get that temperature. Okay? And then finally, let's do our fifth round. We're going to have to mix up. Oop, I see why. You're taking my air molecules over there. Really Move them around, move them around. Very random. Very random. And let's see what we come up with this round. All right, I got all 20 of my molecules. You have your 12 molecules over there. And let's, in the collision zone, let's see what happens this last round. Boom, 1 plus 4 is 5, which is not even, so that's minus 1. Someone's going to have the extra 1. And that would make it 4 divided by 2 would be 2. So air has the smallest number, so air is going to have 3. Cocoa gets 2. So in our papers, air went from 1 to 3. That's a plus 2. And cocoa went from 4 to 2. That's a minus 2. Next molecule collision. Boom, 9 plus 5 is 14. 14's even, divided by 2 is 7. Both of those are going to be 7. Air went from 5 to 7, that's a plus 2. Cocoa went from 9 to 7, that's a minus 2. Next collision. Boom. 5 plus 4 is 9. That's not even, so let's minus 1 from there. We have that extra 1. That gives us 8 divided by 2, which is 4. So the 1, 2, 3, 4, the one who's going to have the extra is the smallest one. In this case, it's cocoa. So cocoa is going to have 5. Air is going to have 4. And so in this case, the total kinetic energy for air was 5 down to 4, so that's a minus 1 for air. And the cocoa went from 4 to 5, which is a plus 1. Finally, our last one, when we hit, boom, you have 6 plus, is that a 9? 9 gives us 15. 15's not even, so let's minus that 1. Gives us 14. 14 divided by 2 is 7. And so the one who is going to get that extra 1 is going to be air. So 7, 8. And this one is going to 8. So 7. That's why it's really good to have someone, 2 to 3 people helping you, even up to 4 people helping you with this. Thank you. So 6 for air molecules, kinetic energy went from 6 to an 8. That's a plus 2. The kinetic energy for cocoa went from 9 to 7. That's a minus 2. So now we are done with our board game. And again, you are going to be the one to calculate out the total kinetic energies. And when you get to that fourth round for hot cocoa, don't forget to take whatever that number is, divide that by 12 to give you your temperature. Temperature is total kinetic energy divided by the number of molecules that you have. And then same here, but because we had more molecules of air, we're dividing by 20 in that fourth round. So I hope you are going to learn a little bit. I know it's a little math, a little confusing, but I want you to be thinking about this game and what this all means when a hot chocolate is actually cooling down to room temperature. What's the reasoning behind that? So have a great day. Thanks.